Okay, let's take a look at 2014, number 5. Part A. We have a twice differentiable function f and g, and they are defined for all real numbers x. The values for f prime, g, and g prime for the values of x are given in this table, ranging from -2 to +3. They give you the value at -2, and they tell you some things about it in between, -2 and 1. And anyway, we'll get to that. So we're going to find the x-coordinate of each relative min of the function f on the interval from -2 to 3. So that means all the way from -2 to 3, find the x-coordinate of each relative min. Okay, so if I'm looking for mins, I need to find out, I can look at this a couple ways. I need to find, critical points when the derivative equals 0. So I'm looking at the derivative of f, and the derivative is 0 at -1 and also at +1. So those are critical points. But really, the main thing I need to focus on is, if I'm looking for a relative min, when does f prime change from negative to positive? And in this interval, it's negative. The next interval after -1, it's also negative. So that's not going to be a min, but then it changes from negative to positive at x equals 1. So I say f has a relative minimum at x equals 1. It's because x equals 1 is the only critical point where f prime changes from negative to positive. Let's go to part B. Explain why there must be a value c in between -1 and 1 such that f double prime of c is equal to 0. All right, so normally, this might confuse some people because we're trying to find out when f double prime equals 0, but it's the same thing as when you guys before had to say, okay, I know I want to go from f to f prime. Well, now we're going from f prime to f double prime. So it's really not a big stretch. So let's take a look. Why does there have to be value c? Okay, that should immediately tell you the mean value theorem. If there has to be a value c in some intervals such that a derivative is equal to a certain amount, that says mean value theorem all over it. So since we're trying to find a value for when f double prime of c equals 0, we're going to look at f prime. And we're talking about in between -1 and 1. So we're only going to look between -1 and 1, and we're going to look at f prime. We know that f prime of -1 is 0, and f prime of 1 is 0. So f prime of 1 minus f prime of -1 over 1 minus -1 equals 0. That's the average rate of change between -1 and 1 of the function f prime. So that means there has to be some place in that interval in which the instantaneous, that's the average rate of change, there has to be a place in there somewhere where the instantaneous rate of change is also equal to 0. And that's basically it. So my answer is f prime is differentiable. Again, you have to state the hypothesis of the mean value theorem. And it has to be differentiable and continuous. So we know, we were told that it's twice differentiable, so we know its derivative is, it works. It's differentiable, both from f to f prime and f prime to f double prime. So we know that if something is differentiable, it's also continuous. A function is differentiable, a function is also continuous on that interval. So we look at it, do what I did up there at the top a little bit ago. F prime of 1 minus f prime of -1 over 1 minus -1 gives me 0 minus 0 over 2, which is 0. So by the mean value theorem, there has to be at least one c in the interval -1 to 1, such that f prime of c equals 0.